Hello everyone. In this video, I'll be teaching you about one of the most important topics in chemistry, moles, molar mass, and mole conversions. If these concepts feel confusing, don't worry. I'll break them down for you step by step and we'll go through some practice problems. So let's start off with the most obvious question. What is a mole? Well, a mole is a way to count particles, right? A mole is a way to count particles. Such as, and what are particles? They're like atoms, molecules, ions. So, what does 1 mole equal, right? So a mole has a number. 1 mole is equal to 6.022 times 10 to the 23rd. And this is also known as Avogadro's number. So this is a really important number to remember because this is what the whole unit is based around, right? So just the way I like to think of a mole is a dozen. So we know 1 dozen is always equal to 12, right? Well, same as a mole. 1 mole is equal to 6.022 times 10 to the 23rd. So that's the basic. What is a mole? Pretty simple, right? So let's move on to molar mass. So what is molar mass? Well, molar mass is the mass of 1 mole of a substance. And it is measured in grams per mole. So, what does this mean? This might sound complicated, right? You can find the molar mass of any element or compound using the periodic table. For an element, it's just the atomic mass. It's just basically you look at it and you find the atomic mass and there you have it, right? For a compound, you add up the atomic masses of all the elements in the formula, and that's your molar mass. So, grab your periodic table real quick and we'll do some practice problems. So, what is the molar mass of carbon? Feel free to pause the video. So hopefully you got 12.01 grams per mole, right? Let's do another one. What is the molar mass of oxygen? Feel free to pause the video. So hopefully you got 16 grams per mole. Now let's try something difficult. What is the molar mass of carbon dioxide? Feel free to pause the video. So hopefully you got 44.01 grams per mole. So you might be asking, how did we get that? Well, let's see. We found carbon already, right? We found carbon, which is 12.01. We found oxygen, which is 16. And our O2 here represents 2 oxygens. So we just add 16 again. And we do this calculation, 12.01 plus 16, and we get 44.01 grams per mole. So that's molar mass as well. Not too difficult, right? Let's move on to mole conversions. So this is where the magic happens, right? The mole is useful because it connects 3 things. It connects mass, number of particles, and moles themselves. right? So these are our conversions. This is how I think is the easiest way to convert it. So we set up this diagram, particles and moles. So first you draw an arrow from particles to moles, and you draw an arrow from moles to particles, right? And what you do to get from particles to moles is you divide by Avogadro's number. And to go from moles to particles, you multiply as well by Avogadro's number. Right? Now this is pretty simple. So what's our next conversions? We're going to go set it up again, right? Mass in grams and moles. So to convert this, we'll do an arrow from mass to moles and moles to mass. Except our conversion factor here is going to be molar mass. So to go from mass to moles, we're going to divide. And to go from moles to mass, we're going to multiply. Same thing, molar mass. All right. So let's try some practice problems. Okay, so how many moles are in 88.02 grams of CO2? So let's do this together. First, we know we're trying to go from moles to mass. How many moles are in 88.02 grams of CO2? So here we have to figure out what we're trying to go to. We're trying to go from mass to moles, right? So we would use this conversion factor. So we have 88.02 grams of CO2, right? 88.02 grams of CO2. Now let's look at our conversion factors. How would we go from mass to moles? We would divide by the molar mass, which we saw earlier of CO2, which hopefully you have written down, is 44.01, which would equal 2 moles. Very simple, right? Now, you tried this one on your own. How many moles are in 32 grams of oxygen? Feel free to pause the video. Right? Hopefully you got 2 moles. So I'll go through this again. First we have to identify our mass to moles conversion, right? So we're going mass to moles, and our conversion factor is molar mass. So what is the mass in grams? 32 grams, right? And we have to divide, because we see up here what we have to do. We divide by the molar mass of oxygen from before, which we got was 16, and we get 2 moles. Those are pretty simple, right? So let's move on to some more practice problems with particles. Alright, so let's do some particles practice problems. Okay, so here's the practice problem. If you have 3.011 times 10 to the 23rd molecules of H2O, how many moles is that? So let's go through the steps. Step 1. We have to divide the number of molecules by Avogadro's number, as seen over here. We have molecules, and you want to, molecules, which is particles, right? And you want to divide by Avogadro's number to get to moles, right? So we have 3.011 times 10 to the 23rd, and we divide it by 6.022 times 10 to the 23rd. And hopefully, if you put that in your calculator, you get 0.5 moles. So, from that problem, using the 0.5 moles from the last example, let's calculate the mass of H2O. So, let's get the mass of H2O. Use the molar mass here, right? Molar mass of H2O. Feel free to pause the video. So I got 18.02 because it was 2 hydrogen and 1 oxygen, right? 16 plus 1.01 times 2. So now that is our molar mass of H2O. So if you remember from our other conversion, right? If we want to go from moles to mass, so what is moles to mass? You multiply by the molar mass. So what we do here is we do 0.5 moles multiplied by 18.02, and then we get 9.01 grams. So, to recap, a mole is a huge number chemists use to count particles. Molar mass connects grams and moles, and mole conversions let you switch between mass, moles, and particles. Keep practicing these problems, and soon, mole conversions will feel like second nature. If this video helped, don't forget to like and subscribe for more simple step-by-step chemistry explanations. See you in the next one. Thank you.